Welcome to clickmyproject.com, where we discuss about the process exploring visual and motion saliency for automatic video object extraction. Let me see about the process exploring visual and motion saliency for automatic video object extraction. We extract the object of interest, that is the objects present in the video, by utilizing the visual saliency and motion saliency of the object of interest. So for that we are using optical flow map. Optical flow map is used to extract the motion features of the object of interest. Then the extracted features were processed and then fused using conditional random field. Finally, the object of interest is extracted. This process is very helpful in video surveillance and other applications. So initially we are pre-processing the input frames, and then after that we are extracting the we are applying an optical flow map into the video frames, so that we are getting the motion parts, and then we are calculating the shape cues using the color GMM and the motion part tracking processes. And after that, based on the extraction of the foreground objects using background subtraction method, we are extracting the foreground objects, and based on the extracted foreground objects, we are applying the original pixel values from the input video, so that we are obtaining the exact foreground objects present in the video. Let me see the flow of the process exploring visual and motion saliency for video object extraction. So in this process, initially the input video is loaded and it is converted into frames. So all the frames were initially pre-processed using Gaussian filter. So Gaussian filters produce the input in video frames and makes them more clear, so that it is very useful for the further processing. And then we are extracting the visual saliency from the input video. So for that the image is segmented in order to extract the color and the contrast information. For image segmentation, we are extracting the image pixels, that is containing the important information about the objects in the video. So based on this, the visual saliency is detected in the video. And then here motion cue is also calculated. So motion cue is used for tracking the movements in the video. This is done by calculating the motion saliency and shape cue. So for that we are using optical flow map. So the optical flow map detects each moving part in the video and its corresponding pixels. We can perform dense optical flow forward and backward propagation at each frame of the video, so that we are extracting the movements in the video exact. And then based on the visual saliency and the motion saliency extracted, we are calculating the shape cue. So first we are converting the motion saliency images into binary output and extract the shape of the objects in the video. So after that we can get the information from the motion saliency images. We integrate both foreground and background color models with visual saliency and shape likelihood in order to get a unified framework for video object extraction. So finally we are getting the extracted foreground object. Let me see the execution of the process exploring visual and motion saliency for video object extraction. So if you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the guide window which is needed in order to run the code. So first load the input video that is given by us. The input video is loaded. So it is loaded and that is displayed in this respective position. Then after that frame conversion. So the input video is converted into frames. Then we apply pre-processing. Here we use Gaussian filter for to remove the noises from the input frames. So the images were pre-processed and the result is displayed here. Then we generate the optical flow map for the input object. So here the optical flow map is generating. Now all the optical flow map is generated, so this will take some time. And after the optical flow map has been generated, then we go on to the foreground object extraction process. So in this process, first we are identifying the motion parts in the video. So for that we are getting this result like this. So we are identifying here the motion parts, and then we are extracting the shape likelihood of the objects, and then we are using some color GMM. So here we are applying color GMM to get the values, and then finally we are extracting the objects, which foreground objects which is presented in the video. So this foreground objects will produce the segmented objects. So in this video these two persons were present, so these two persons alone were segmented and the background regions were eliminated. So these were segmented and the results were stored in the original object folder, and then also the values were the detected objects were stored in the detected objects folder, and this will contain some black and white images of the input objects. So here we are obtaining the color objects, exact foreground objects which is present in the video. So thus we are extracting the foreground objects from the video based on the optical format generation and the motion part calculation and the shape likelihood identification, and finally using color GMM. So thus we can able to segment foreground objects alone from the input video that was given by us. Thank you.